students, today in electrostatic potential and capacitance we will discuss some numericals based on electrostatic potentials. Okay, so first numerical is given here. Two charges 5 into 10 to the power minus 8 coulomb and minus 3 into 10 to the power minus 8 coulomb are located 16 centimeter apart. At what point on the line joining the two charges is the electric potential zero? Take the potential at infinity to be 0. The potential at infinity is 0. So we have to calculate that what will be the position from the charge. Now we have two charges. Say one is this 5 into 10 to the power 5 into 10 to the power what minus 8 coulomb, and the other charge is, say, it is minus 3 into 10 to the power minus 8 coulomb. And say there is a point here somewhere at this point, and the total distance is, say, it is 16 centimeter. So very simple, what we can take is that if this distance is x, so it will be 16 minus x. And at this point, the net potential is 0. Net potential is what? V1 plus V2 is what? 0. And what is V1? It is K Q1 by R1 plus K Q2 by R2 is equal to what? 0. Now if you see this Q2 is basically the negative 1, and then Q1 by K will go down, and we can write Q1 by R1 plus Q2 by R2 equal to 0. What is Q1? Is 5 into 10 to the power minus 8 upon x, and what is Q2? It is minus 3 into 10 to the power minus 8 upon 16 minus x equal to 0. So we'll take it on this side. It will be 5 into 10 to the power minus 8 by x equal to 3 into 10 to the power minus 8, 16 minus what? X. So this will go like this. Then this will be what? 5 by x equal to what? 3 upon 16 minus x. Okay. After this step comes 10 to the power minus 8 cancels out, and you solve it. It will be cross multiplication 5 into 16 minus x equal to what? 3x. And by solving it, you get what? I'm writing it directly. 8x equal to what? 80. So what is x? Is 10. So x is 10 centimeter from what? Plus 5 into 10 to the power minus. So this is the answer. X equal to 10 centimeter. So this is the position from 5 into 10 to the power minus 8 coulomb. Now the second question. Got it? So this is the first question. Second question is calculate the potential at the center of the hexagon, side 10 centimeter and charge 5 microcoulomb at each of its vertices. Now we know that we have a hexagon like this, and this is a hexagon, and we all know that an hexagon with the center, it forms an equilateral triangle. The sides are same. So we have what? 5 microcoulomb, and the side is 10 centimeter. So we know that this is 5 microcoulomb, 5 microcoulomb, 5 microcoulomb on all the vertices, and the side is what? 10 centimeter. So that means all the sides from the center will also be 10 centimeter equilateral triangle. What is the net potential? Will be what? Do you know? V1 plus V2 plus V3 plus V4. It follows additivity. Already we have explained it. So it will be 6 times V1. So V will be 6KQ by what? R. So I think we can directly multiply. K is 9 into 10 to the power 9. What is Q? 5 into 10 to the power what? It is minus 6. And the sign, this is distance 10 centimeters, 10 into 10 to the power minus 2. So if you solve it out, it becomes 2.7 into 10 to the power 6 volt. So you solve it out, it will be 10, 5 6 is 30, 9, 27, and then you solve it out. This will be the answer. So we can calculate, we can have a square and equilateral triangle or hexagon. Net potential will be very simple. This is the value. Now to come to the third question. Third question is a charge 8 millicoulomb is located at the origin. Calculate the work done in taking a small charge of minus 2 nanocoulomb from a point P to point Q, P003 to Q040 via point R, 069. So the coordinates have been given and we have taken this charge from P to Q. So we have to find out the work done. Now we know that work done is final potential energy minus what? Initial potential energy. And if you want to draw the diagram, we can even draw it, though we know that it depends on final and the initial distance. This is x-axis, this is z, and this is what? Y. We have taken like this. Now this point is P, and P has a coordinate 0, 0, 3. And this is a point Q. This has a coordinate 0, 4, 0. Okay. And we are going through the point, say, via R. We have considered it. So R is what? 0, 6, 9. We are going from P to Q via R. But do you know the work done depends on the final and the initial distance. This is the final distance and this is the initial distance from the origin. So what will be the work done? I think all of you know K Q1 Q2 by what? RB minus K Q1 Q2 by what? RA, which is the final distance from the origin. RB and initial is RA. It doesn't depend on this point. Final because it's a conservative force. So finally we can write K Q1 Q2 in bracket 1 upon what? RB minus what? RA. So we have to solve it. What is K? It is 9 into 10 to the power 9. What is Q1? Is, say, at the center, it is 8 millicoulomb. So 8 into 10 to the power minus 3. And what is Q2? It is minus 2 nanocoulomb. So 2 into 10 to the power what? Minus 9. RB is what? It is 4 centimeter. So 0.04 and it is what? 3 centimeter. So 0.03. So solve it out. If you solve it out, it becomes 144. 69 to 144 into 10 to the power minus 1, and in bracket it becomes 3 minus 4 by 12. And when you solve it out, it becomes 1.2 joule. So this is the work done. This is minus, and minus minus will make it plus. So this is work done. Work done is final minus what? Initial. Solve it out. So you'll find that it doesn't depend on the point R because it's a conservative force. Now the next question. Next question is very simple. Again, it is on the additivity. A cube of side B has a charge Q addition. So if you want to make a cube, you can draw it like this. There is a cube and we have to calculate the net potential at the center. And do you know this is the diagonal of the cube. And again, all the charges are given Q, 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 and the side of the cube is this. So this distance from the center, I think all of you know the distance from the center, the total diagonal length will be what? Root 3b, because side is b. So distance will be what from the center? It will be root 3b by 2. So this will be the distance, half of the diagonal. This is diagonal, okay, of a cube. Now, what will be the net potential? How many charges are there? 8. So we know that V1 plus V2 plus V3 plus V4, V5, V6. It's very easy because it follows additivity. Potential has no direction. 8 times V1. So 8 times of KQ by R. So 8 KQ by what is R? R is root 3P by 2. So solve it. Final answer will come here, and that will be V equal to what? 16 KQ by root 3V. This is the answer. And if you want to follow the value, K is 1 upon 4 pi epsilon naught 16 Q by root 3B. And the electric field at the center of the cube will be what? 0. Why? Because all pair of vectors cancel out each other. Question number 5th, if you go through it, the two charged conducting spheres of radii A and B are connected to each other by a wire. And if radii A and B are connected to each other by a wire, what is the ratio of electric field at the surfaces of the two spheres? We have to find out the ratio of electric field. So very simple. Say we have two conducting spheres like this. One is of radius A, other is of radius B. If they are connected by wire, do you know if you connect them by wire, what will happen? All of you know that they will have the same potential. So V1 will be equal to what? V2. So what is the V1? 1 upon 4 pi epsilon naught. Say the charge on this is Q1. So Q1 by what? R. And what is V2? 1 upon 4 pi epsilon naught. We know that Q2 by V. So this will be a relation. You will get it from here. Q1 by Q2 is equal to what? A by V. You got the ratio of the charges. Why? Potential will be what? Same when you connect it by wire. This is the concept. Now, simply what is the ratio of the electric field? All of you know E1 will be what? What? K Q1 by A square, and E2 will be what? K Q2 by what? B square. This is the electric field. So find the ratio. So if you write E1 by E2, it will be what? Simply Q1 by what? Q2 B square by A square. Got it? And then you put it A by B here. So A by B, B square by A square. So got it? B equal to B. So what is the answer? Is B by A. So finally the answer is E1 by E2 is what? B by A. This is the ratio of the electric field. Very easy question and important, because the potential is same. You get the ratio of the charge, and then we know that this is the electric field. You get it ratio, and you will find it that it is B by A. The charges are not same. Charges will be different. Okay, the next question. Now, next question is what? If you see, the next question is of 500 microcoulomb charge is at the center of a square of side 10 centimeter, and then find the work done in moving a charge of 10 microcoulomb between two diagonally opposite points on the square. Now, if I have a square like this, and say these are the 2 points which are diagonally placed, and they are like this, and at the center we have 500 microcoulomb, and we are taking what? One charge 10 microcoulomb on the opposite sides. So we will take 10 microcoulomb this is 10 microcoulomb we are taking from A to B. Simple. So, and do you know, because this surface will be an equipotential surface, VA will be equal to what? VB. If we take from this, what is the work done is QVBA. We have taken from A to, so QVB minus VA. Do you know this work done? We are taking from A to B, so final potential minus initial. And as we know that potential is 0, finally the work done will be 0. Remember, work done on equipotential surface. If there is another point C, and if I ask you what is WAC, you know again it will be 0. Why? Because VA is equal to what? VC. So this is very simple, one mark question, that this becomes an equipotential surface and the work done is 0. So this is the 5 number 6. Now there is another question, question number 7, and question number 7 is very important. If you see, this question is 3 concentric metallic cells ABC of radii A, B, C are given, and the figure is given: A is less than B, less than C, have surface charge density plus sigma minus sigma plus sigma. If cell A and C are at same potential, then what will be the radius among them? What will be the relation among A, B, C? These are the 3 concentric cells. One is A, B, C. Their radius are given and their densities are given. Okay, so we know that. We will find out first the charge. Now charge on cell A And I think most of you know, say the charge is QA, and charge is sigma into what? The surface area. What is the surface area? 4 pi square. Similarly, charge on cell B. Charge on cell B will be what? QB. But this time you know that on B it is negative, so minus sigma 4 pi B square. And then charge on cell C, the outer one, QC will be again sigma, but this time the area is 4 pi what? C square. You know how it came? Sigma is charge per unit area. All of you know Q by S. So you can find out the charges of the three cells. Now first we will calculate it on A, then on B, and then on C. So potential at A. What will be potential at A? I think all of you net potential will be V1 plus V2 plus V3. So we can calculate it. VA will be 1 upon 4 pi epsilon naught. I think QA by what? A plus QB by B plus QC by C. So put their values. Finally, when you put their values, I think all of you know what is the value of QA. Sigma 4 pi A square by A minus 4 pi B square sigma by B plus 4 pi C square sigma by C. So take it common. Do you know 4 pi will cancel out? I am writing the final answer for VA, and for final answer for VA will be what? Sigma by what? Epsilon naught. In bracket it will be what? A minus B plus C. Why? Because A cancel out, B cancel out, C. So this is the net potential at what? VA. Similarly, you can find out the net potential at VB. What will be the net potential at VB? It will be the same what? V1 plus V2 plus V3, but this time, do you know, VB 1 upon 4 pi epsilon naught, and I am going to write it. It will be the same way, you know, that QA. But now the radius will be what? Not A, B, because it is on B. So QAB plus QBB plus QCC. Got it or not? Why I have taken B? Because it is on the what? This one, B. So if you put the values of QA, QB, QC, again, you know that sigma by epsilon naught, it will come out, and in bracket, it will be A square B minus B plus C. You put these values, you will get this answer. So this is VV. Got it? Why we have taken B? Because it is now on the cell B. Now similarly, we will take on what? C. See, VC will be V1 plus V2 plus V3. And you know, VC will be again the same 1 upon 4 pi epsilon naught. In bracket, can anyone tell me what will be the answer? QA. Now the distance from A will be the outer because it is outer. So QA by C. From B it is also outer. So what it will be? QB by what? It will be QB by what? Again it will be C. And from C it is QC by C. Got it or not? Why we have taken what? C? Because we are taking the outer distances. And then you solve it, you will get sigma by epsilon naught, and I'm going to write it. It will be A square by C minus B square by C plus C. So this will be for BC. This is a very important concept. You take the outer distances when you take from the cell. So VA, VB, BC. And what is the last thing is that if A and C have the same potential, then what you do that you make VA and what VC same. You put the value same, and when you put the value same, the relation you will get will be A plus B equal to C. So put them same, because the potential, if they are same, then this will be the answer. So this is a very important question. How you got it? You know that net potential on A, then net potential on B, then net potential on C, and do you know what you calculate? It is when you take the B, the distances will be the outer one. When you take on C, the distances measured from the center will be the outer one, and then you relate VA and VC. So this is question number 7, very, very important. Okay, now come to the question number 8. So what is question number 8? Is a charge Q distributed over the surfaces of two concentric hollow spheres of radii R and R such that their surface charge densities are equal, determine the potential at the common center. So we will do the solution of this, how we are going to calculate it. So solution is what? A charge q is distributed over the surface of, so we'll take two concentric, say there are two concentric like this. Now this is a radius r and the outer one is capital R. Okay, and say one has q2 charge and another has q1 charge. We have taken the two charges. So total charge is q, we have distributed into q2 and q1. q2 plus q1 is total q. Got it? And what is the same is that the two have the same charge density. What is charge density? Sigma is equal to what? It will be q1 upon 4 pi r square, q2 upon 4 pi what? Capital R square. Sigma is given same. So can we get q1? Yes, 4 pi r square sigma, and q2 we can get 4 pi r square sigma. It is capital R and it is small r. So net charge, can we get it? Yes. We solve it, we will get the net charge, and net charge will be 4 pi sigma in bracket r square plus r square. So this is the net charge. We got it in the terms of sigma. And that means sigma can also be written as q upon 4 pi. Okay. And it is r square plus r square. So you can write the sigma in this term also. Now the net potential will be what? V1 plus V2, again the same thing, additivity. What is V1? 1 upon 4 pi epsilon naught. In bracket it will be Q1 by R plus what? Q2 by R. So you solve it out. When you solve it out, you put the values of it. 1 upon 4 pi epsilon naught in place of Q1. You will put 4 pi R square sigma by R. And in place of Q2, you will put plus 4 pi R square sigma by what? R, and you solve it out. Do you know what you get? Is that R plus R into what? Sigma by epsilon naught. You will get by 4 pi will cancel with 4 pi, R square will be R, and from here it will be single R, and from here it will be capital R. So you will get this and put the value of sigma. Now what is the value of sigma? This one. And finally you get 1 upon 4 pi epsilon naught Q R plus R upon R square plus R square. So this is very, very important question. The earlier question was also important. This will be the net potential at the common center O. How you got it? Sigma is same. Then you calculated Q1, Q2, then capital Q was calculated, then sigma, then net potential, and then put the values. How we can calculate. Now the next question is, if n drops of same size each have same charge and collects to form a bigger drop. You know that n drops form a big drop. You have gone through in class 11th. Surface tension and terminal velocity same. A total charge on bigger drop and potential on bigger drop. Do you know what was the case when you take, you know that the volume remains same. Volume of n drop will be volume of what? Small n drop. So what was the volume? If you relate it, the volume of what? N drop will be n 4 by 3 pi r cube. This is the n drops when you turn. And then what is the volume of n bigger drop will be 4 by 3 pi r cube. So you can relate it. You know, you get a relation that is n r cube will be equal to what? R cube. So can I write n 1 by 3 r? Yes. This we have done. What will be net charge? Net charge is very simple. Net charge follows additivity. It will be NQ. Net charge will be the sum of the total charge of the drop. Q is the charge on a small drop. And what will be the potential? Potential of small drop is KQ by R, and potential of big drop is KQ by R. So you replace Q and R from here. Finally, V will be what? If you put it here, 1 upon 4 pi epsilon naught. In place of Q, it will be NQ, and in place of R, it will be N1 by 3R. So finally, what you get, you take it on the other side, and the answer you will get will be N1 by 3 will be N 1 minus 1 by 3, 2 by 3, and 1 upon 4 pi epsilon naught q by r is what? Small v. So this is the potential. That means v by small v will be n2 by 3. So this is the answer, that this answer you will get for the potential. So potential on bigger drop will be n2 by 3 times of the small drop. So drop cases you have done, you see that how this is followed. So this is how we can do. Now question number 10 and 11 and 12. Now this figure shows the variation of potential V with the distance x for a given charge distribution from the points marked A, B, C. Identify the point in which electric field will be what? 0, and electric field marked on 0 and maximum. I think 0 you know. How many of you know that this is the graph between V and X, and how many of you remember how V and X are related with the relation minus dV by dx? This was potential gradient. And if I ask you potential gradient at point A, can anyone tell me, yes, what is the potential? Potential is constant. Okay, so at point A, dV by dx will be what? 0. And at point B, when point B, you know that it is going to drop down now, so dV by dx will be what? Less than 0. It is going down. And at point C is going up, so dV by dx will be what? Greater than 0. So E is 0 at what? A. 0 at A. And E is maximum what? At C. Very important question, potential gradient. This is what? Where the electric field is 0. It is what? dV by dx is what? Less than 0, and at C dV by dx is greater than 0. Now the electric field V is given by this. Calculate the potential at 1. So x, y, z you have been given the what? The potential, and the potential has been given by V equal to 4x square. And how many of you know that you have to find out? Again, V is the function of x. We know that E is minus dV by dx. You relate it, what you will get? E minus d by dx of 4x square. And all of you know minus 4x square is 2x. It will be minus 8x. Okay, got it? And what is the coordinate of x? X here is 1 meter. So what is electric field? Is minus 8 Newton per Coulomb. Got it or not? And when you are going to write it in the form of vector, we can write minus 8 what? I. So this is the electric field here. And the last one is how you make ER and VR graph for spherical charge spherical cell. You remember charge spherical cell? You have gone through the Gauss theorem. So this was the graph. You remember it for the charge spherical cell. And then what will be VR graph? I think you can relate it. Here the electric field is 0, the potential will be constant, and for outer it will be like this. This is VR graph. E is inversely proportional to R square, V is inversely proportional to R. So these are the questions which are related with the what? Electric potential, ER graph. You have gone through Gauss theorem. VR graph will be this. Here E is 0, V will be constant, and this is the relation. So thank you for in this video. For this video we have discussed all the numericals, and go through all it intensively and watch my videos.